Windmills were widespread throughout the Aegean from at least the 16th century. They were particularly common in areas where there were no rainwater collecting ditches able to sufficiently support the functioning watermills throughout the year. There were several types of windmills. The windmill presented here is a 3-story tower in the shape of a truncated cone. The roof of the windmill is a movable rotating cap, connected to the rotor mechanism, which has 4 sail stalks. The internal structure includes a stone-built staircase. The orientation of the rotor according to the wind direction required a movable cap, i.e., a wooden structure that turns at the top. The movable cap would sit on a stable circular wooden base built on top of this tower's masonry walls. This base or ring was supported on crossbars. On top of this ring there was a second movable ring, supporting the movable cap, which rotated on the stable bases together with the wind shaft, the wheel, and the rotor. To rotate the cap, millers inserted a lever into the holes of the movable ring, and pushing against vertical movable wooden pegs fixed in the stable ring, the lever caused the rotation of the cap. The moving mechanism, known as a sail frame, was attached to the part of the wind shaft projecting from the cap. The wind shaft was a thick wooden axle at least 7 meters long, 35 to 40 centimeters thick. It did not sit directly on the movable basis of the cap, but on wooden supports called cushions. The sail stalks were beams used for attaching the sails. Their length and thickness depended on the height of the tower, the size and number of sails, as well as the construction of the mechanism and the tower. Sail stalks were fitted on the wind shaft with tenons. The tenons defined the incline of each sail stalk. The sail frame had 2 braces, the rigging holding it on the front side, and the contour, which was tied peripherally from one sail stalk to another. The sails were triangular lateen or jib-type sails. One of the long sides of the sails was attached to the sail stalk with a strap, while a halyard, sewn on the free tip of the sail, was used to regulate the surface of the open sail when the windmill was milling grain. The sails were trimmed according to wind velocity, in order to catch the wind and harness the wind power required to rotate the runner stone, i.e., the rotating top millstone. The wind shaft converted the movement of the sail frame into the brake wheel, which was attached to the middle of the wind shaft. The wheel transferred the movement to the wallower via special cogs. The wallower was located in an upright position at the bottom of the brake wheel, exactly at the center of the tower. Driven by the brake wheel, it then transferred the movement to the runner stone via the upright shaft. The shaft was one of the few components of the mechanism made of iron. The upper part of the shaft was embedded firmly in the center of the wallower to prevent loosening. The cylindrical top end of the shaft was fixed into the bridge beam, a wooden construction vertical to the wind shaft. The bottom end of the shaft passed through the eye of the runner stone, that is, the central hole in the runner stone through which grain entered, and ended up in a fork which clasped the bridge, in the shape of a symmetric double-headed axe. Through these connections, the upright shaft took the movement from the wallower and transferred it to the runner stone through the bridge. The runner stone had grooves cut into its grinding surface, which assisted the even distribution of the grain during milling. Under the runner stone, the bedstone, i.e. the stationary bottom millstone, was set on a round bed of masonry built on the flooring planks of the upper floor. In the middle of the bedstone there was an opening, closed by a circular piece of wood with a smaller opening. The quant, a shaft both supporting and rotating with the runner stone, went through this opening and connected to the bridge. The quant was supported by a wooden base attached to another piece of wood parallel to the windmill floor. The grinding mechanism feeding the millstones with grain had two main wooden components, the hopper and the shoe. The hopper was a funnel-shaped container, open at the top. It hung from 4 ropes, 2 attached from the bridge beam and 2 from the cap beams. The hopper was filled with grain from above, which emptied slowly through a small square hole at the bottom into the shoe. The shoe was a small channel in the shape of a long, narrow trough. It was located between the hopper and the runner stone, with its narrow end right above the eye or opening of the runner stone, and its wide end under the spot where the grain from the hopper would flow. A short piece of rope attached to the bridge beam regulated the tilt of the shoe and the amount of grain fed into the eye of the runner stone. The bed stone was girded with a wooden casing made of hardwood, which was built on the stone base. The casing had rectangular holes every 40 centimeters or so, where vertical pieces of wood called keys were placed. These supported wooden planks, which were slotted in to form a vat for holding the ground grain. The whole construction was called a bumper. Between the bumper and the millstones there was a gully where the ground grain was collected, and a bit lower a hole through which the ground product would flow into the flour chest. To adjust the gap between the grinding millstones, 2 methods were used. In the first case, a horizontal wooden beam called the table was raised using wooden wedges that were set in the stand, which was a vertical beam. One end of the beam was set in a recess in the windmill wall, and the other was attached to the stand. Alternatively, one other end of the beam was supported with a second stand. In the second case, a wheel was used to make the adjustment. One end of the beam leaned on the wall, whereas the other end was connected to a vertical piece of wood, which went through the upper floor and lifted a mechanism known as the wheel. To stop the windmill, 3 different systems of the moving mechanism were used. These 3 systems functioned independently and/or in combination with one another. In the first case, a rope with an iron hook tied at its end was used. When the miller wanted to stop the movement of the sail frame for a short time, he used this rope to catch the end of one of the sail stalks, and, pulling it with all his strength, he gradually decreased the movement until it came to a complete stop. Then he tied the rope to one of the rings fixed in the wall of the windmill. Secondly, the simplest way to stop the movement of the sail frame was to apply a brake using the runner stone. To achieve this, the miller increased the amount of grain to avoid friction between the grinding stones and loosened the ties of the wheel. This way, the runner stone would weigh heavily on the bedstone. Finally, they would use a special type of rope as a brake. The rope was loosely tied around the windshaft where there was a collar of planking. To stop the windmill, they tied one end of the rope to a stable point, usually located on the stone wall of the windmill, and hung a weight from the other end. This way, the rope tightened the collar and slowed down the rotation of the windshaft. In practice, millers used the above systems in combination.